purpose of this demo is to show how ChatGPT can be used for metadata mapping and how much more sophisticated the mapping methodology is. And most notably, I want to show how it compares to standard fuzzy matching. And the example I want to give is Jarrow-Winkler, which is a mapping algorithm that looks at a text string. Is probably the most commonly used, and basically it scores a match based on how many keystrokes it would take to make one text string look like the baseline text string. So let me give you the most obvious example here. Would be loss description. Let's just take loss description for example. So that's the benchmark is for comparison is loss description. Here it's called incident description. And so using Jarrow-Winkler, it would score this as a moderate because it would take X number of keystrokes to make the string incident description look like loss description. It's probably about 10 or 15 keystrokes that it would take to make it look like that. Probably a more appropriate one would be this comparison of claimant zip versus postal code. And so Jarrow-Winkler would score a match very low on this because basically you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 keystrokes to make the string claimant zip disappear and then replace it by postal code. I mean, the text strings are completely dissimilar. So I want to demonstrate how ChatGPT and the general language model is way more sophisticated in terms of doing a mapping exercise. So I'm going to open up ChatGPT. And I'm going to start with a new chat. I'm going to feed it. And these are the values on the left here of the spreadsheet are the target table. And you can see it's already created a table just to consume the data. And you can see it's created the table. It has 65, I think that's the count I had. Yep, 65 records. Can you add a column to the left called transformation? And then a column to the left of that called source column. And you reverse the two first columns. in the source column, can you place items from the list below, mapping them to the column, name column, logically? In some cases, multiple columns will map to a single column and column name. In such cases, can you coalesce the column names in the source column and state rules for concatenating them in the transformation column? Here's the list. So this list I'm going to grab, very dissimilar in terms of just the style, right? It's camel case. Everything about it is pretty dissimilar, and that's what you run into a lot in the industry. You don't find this happens all the time. So I'm going to paste my list in here. Let's see what happens. Okay, let's take a look at this. This is what I was talking about. Using a standard fuzzy matching in Python or whatever the tool it is that you're using, you would never ever get a match on claimant tax ID to Social Security number. This one should have. I think I have an affiliate claim number that it should have put the TPA. So it's not perfect, and it tried to concatenate the claim number with the TPA claim number. But look at this one: source record ID to claim ID. No similarity whatsoever. Incident receive date to claim date, status. Claimant first name, claimant last name, coalescing them into claimant name, address 1, address 2, claimant phone. And then it, without me even telling it, it kept the column names that didn't match. So all my target column names, it kept them intact. I didn't even prompt it. I've actually tried this version. I've actually done this a few times, and each time I've explicitly told it to keep the values in the target table, even if there was no match. So let me ask it one more question. So this is, you could download this now in ChatGPT, and which is not something you could do before. You used to have to copy and paste into TextPad and create delimiters, and the whole thing was pretty messy. But here it is. This is about 2 hours worth of work that was done in less than 10 minutes, maybe even more than 2 hours worth of work, because some of these it's done, and you could go back to the client and verify with the client and have conversations. At least it gives you the talking, gives you something to talk about in terms of suggested mappings. So that was mainly what I was trying to show, was that with classic fuzzy matching algorithms, you're not going to get the kind of sophisticated matching output that we're showing right here, just in the first 3 or 4 lines of this.